Very good evening, sir.
Good evening.
So, again, a warm welcome and very good evening to all organizers, all dignitaries, esteemed faculty members, our respected resource person, Dr. Suresh Kumar Sharma, sir, and all delegates presented in today's session of Fundamental Certificate Program on Effective Research Writing. It is with great pleasure and respect that we introduce today's resource person of the certificate program, Dr. Suresh Kumar Sharma, sir, an esteemed professor in the Department of Statistics at Panjab University, Chandigarh. Sir's illustrious career is marked by significant roles, including serving as the ex-chairman of the department from 2006 to 9 and as ex-coordinator of the Center for System Biology and Bioinformatics from 2010 to 2018. Dr. Suresh Kumar Sharma Sir's areas of interest encompasses a wide range of disciplines, including biostatistics, statistical modeling, distribution theory, statistical genetics, and bioinformatics. With an impressive 27 years of teaching and research experience, Sir has made substantial contribution to both academia and applied research. Sir has undertaken numerous significant projects that demonstrate his expertise and dedication to public health and research. Some of them are like the public health and pollution control in Asia, in collaboration with the Health Effects Institute, Boston, USA, and the professionalization of youth work in collaboration with the Commonwealth Secretariat, UK, the National Health Profile of India, a multi-centric study to assess the exposure and health effects of pesticides in collaboration with PGIMER, Chandigarh, and ICMR, New Delhi. Research on the role of biomarkers in detecting early pregnancy complications in collaboration with ICMR and Genetic Center, GMCS, Chandigarh, and many more. Dr. Sharma's prolific academic output includes more than 135 research papers published in national and international journals after a few. He has attended and delivered talks over 38 international conferences abroad and delivered more than 1,000 invited talks across India. Additionally, he has conducted approximately 300 workshops on statistical software and methodologies, including SPSS, Minitab, R, Stat, Topics, Statistica, comprehensive meta-analysis, and structural equation modeling through MOS. He has also contributed chapters to several books. Dr. Sharma has honored with numerous awards and recognitions, including Best Research Award 2003, Medical Research, and New Delhi, Jacob Wolf Award 2003 by USA, Advisory Board Member, London School of Management Education, London, Visiting Professor at the National Institute of Health, uh, Bethesda, USA, and the Visiting Scientist at National Institute of Health. Appointed Ambassador at the Advisor International Medical Olympiad Association in Greece, Best Paper Award in Meta-Analysis Conference at BHU in November 2017, Chief Statistician, Global Harmony Association Project, Sweden and Russia, and many more. Dr. Sharma has visited numerous countries, including the USA, UK, Austria, Singapore, Malaysia, Indonesia, Hong Kong, Germany, Korea, Qatar, China, Burma, Bhutan, Thailand, Portugal, France, Switzerland, Sri Lanka, Bangladesh, Finland, Greece, Luxembourg, Belgium, Netherlands, Sweden, Turkey, Spain, and Hungary, etc. Sir has in guided and supervised 12 PhD students, currently 4 enrolled. 4 students completed projects in the area of bioinformatics. Dr. Sharma is a member of several prestigious national and international committees, including Forum for Interdisciplinary Mathematical Society, London School of Management Education, National Institute of Health, USA, Health Effects Institute, Boston, USA, International Medical Olympiad, Greece, VA Medical Center, Dallas, Texas, USA. So, without taking too much time, today we are privileged to have Dr. Suresh Kumar Sharma sir to share his expertise and insight with us in this session. Please join me extending a warm and enthusiastic welcome to Dr. Suresh Kumar Sharma sir. Please, sir, welcome, sir.
Okay, good evening and welcome to all the participants. First of all, I would like to thank Dr. Shubham Pandey, the National Coordinator, as well as Dr. Amit Tiwari, who has just introduced me of the Institute of Applied Statistics. In fact, this is going to be a basic lecture on correlation and regression analysis, and hopefully many of the participants, they must have some background of statistics. How many lectures of statistics have been conducted so far? If
Sir, around more than 50% program is completed. This is 1 month program, and all
okay,
basic concepts are clear, like parametric tests, non-parametric test concepts, and topic selections, methodology section. These topics are
okay.
covered.
And the participants' background is from not of all of from statistics. They are from different
Uh,
backgrounds, hopefully.
they are from statistics, biostatistics, and majority are from medical, allopath, and Ayurvedic background. And the majority of the participants are faculties at different prestigious institutions.
Okay, all right. So why I ask these questions? Because I have come to their level to explain all the things. Anyhow, all right. So welcome once again, and I will start with let me share the screen, and then I'll start with the correlation regression part. It's a very important part as far as statistics is concerned, and particularly very useful in medical sciences, biological sciences, as well as social sciences. So let me share the screen. And just give me 1 minute. Can you see my screen here?
Yes,
Is it
yes,
visible?
yes, yes, sir. Visuals.
Okay. All right. Is this PPT visible?
Yes, visible, sir.
All right.
Yes, perfectly visible.
All right. So this is a certificate program on effective research writing, in fact, and I'll be covering this correlation and regression part. Now, before coming to correlation regression, I think our time is up to 8:30, right?
It's 7:30 to 8:30. Yes, yes, definitely. But
So
10 to
can I take 10 minutes extra because 10
yes,
minutes have
no,
already
no
been
problem.
lost.
No problem, sir. No problem. There is no bar.
Okay. All right. Thank you. Thank you. So I'll be covering this correlation and regression. Before coming to correlation and regression, it's very important to understand the nature and types of data, because many of the correlation, many of the regression techniques, they will ask you your data is on which kind of scale and how you have measured the variables. So I'll take just 5-6 minutes to explain you the nature and types of variables, and then I'll move on to the main topic of correlation regression. All right. So if you look at the nature of the data, it is basically of two types. Any type of data, either it is called a structured data or it is called unstructured data. Now, what do you mean by structured data? Structured data is the one where features can be easily extracted. For example, if I give you 100 observations, say relating to height or weight or BMI, and I ask you to compute what is the minimum value, maximum value, mean, median, mode, skewness, kurtosis, percentile, decile, everybody can compute because they are numeric figures. And most of the time, the structured data is in the numeric form. But what happens sometimes the data may not be exactly in the numeric form, but the data is easily convertible into numeric form. And this kind of data is also counted under structured data. For example, gender. Now, gender is not numeric as such. It's simply a label, male and female. But I can always assign certain codes, say male as 1, female as 2. So it becomes numeric. So this kind of data also comes under structured data. Similarly, religion. I can write Hindu as 1, Muslim as 2, Sikh as 3, Christian as 4, or you can write Sikh as 1, Muslim as 2. It doesn't make any difference. So it's easily convertible into numeric form. Similarly, socioeconomic class, say lower class as 1, middle class as 2, upper class as 3. Although initially it is labeled lower, middle, and upper, but easily convertible into numeric form. This kind of data is also counted under structured data. So what is basically structured data? Either it is already in the numeric form like age, height, weight, etc., or it's easily convertible into numeric form by assigning certain codes. So this is what we mean by structured data. Hopefully the terminology is clear to you. Then there is unstructured data. What is unstructured data? Unstructured data is the one where features are not easy to extract. For example, everybody is using WhatsApp. You are receiving messages, videos, pictures every day. And there are a lot of messages. And if at the end of the day, I ask you to convert this entire information into numeric form, which is in the textual form, basically the data is in the textual form, it's not easy for anyone, but it contains information. So this kind of data, which is not in the numeric form, but it is in the textual form, comes under what is called unstructured data. It's easier to deal with structured data, very difficult to deal with unstructured data. And two of my students from statistics and two from bioinformatics, they have completed their PhD on unstructured data. If you give us any text, maybe 8 to 10 pages or 15 pages, doesn't matter. In 5 minutes, without reading the text, we can tell you what they are talking about. So we have derived certain rigorous techniques, but as far as this certificate program is concerned, I'll not focus on unstructured data. I'll focus only on structured data. Structured data means which is in the numeric form. And people also talk about these days big data. Big data is nothing but a combination of structured and unstructured data. Some part may be structured, some part may be unstructured data. Okay, so as I mentioned that I'll focus only on structured data, which is in the numeric form. If you look at any kind of structured data, it is basically of two types. Either it is called categorical data or it's called measurement data. What do you mean by categorical data? Already give you an example like gender. I can write male as 1, female as 2. Socioeconomic class, you can write lower class as 1, middle class as 2, upper class as 3. So this is what do you mean by categorical data. And what's the measurement data? Measurement data means some kind of instrument is being involved in measuring something. For example, you can measure height, you can measure weight, blood pressure, cholesterol, skin fold thickness, chest measurement. So some kind of instrument is being required to measure. But sometimes you don't require any instrument, but still it could be a measurable quantity. For example, to measure age, we don't require any instrument, but age can be measured in years. You can add months, days, minutes, and seconds. So it becomes a measurable quantity. So hopefully the difference between the categorical data and the measurement data is clear to you. These are examples of categorical data. For example, hair color could be brown, red, black. I didn't put a white there because people sometimes get depressed. Our entire body is made up of 4 types of nucleotides. They are known as ATGC. So in hair color, you can give the code as 1, 2, 3. In nucleotides, you can give the code as 1, 2, 3, 4. Eye color can be coded as 1, 2, 3, 4. Gender can be coded as 1 and 2. Disease, mild, moderate, severe, you can write 1, 2, 3. And genotypes, which one is dominant, which one is recessive, depending upon that. If it is small, both of them are small h, that means both of them are recessive, you can write 0. If one of them is dominant, another is recessive, you can write 1. If both of them are dominant, you can write 2. So these can be written as 0, 1, and 2. So all this kind of data, which was not initially in the form of numbers, is easily convertible into numeric form. This is what we mean by categorical data. Measurement data is self-explanatory. I have already explained, like cholesterol, height. And if you look at any kind of measurement data, it is basically of 2 types. Either it is called a discrete measurement or it is called a continuous measurement. Now, what do you mean by discrete measurement? Discrete measurement means if certain isolated values are present in your data, then it is a discrete measurement. For example, number of students present in the class, number of errors in the book, number of members in a family. The number of members in a family may be 3 members, 5 members, 7 members. I cannot say number of members in a family is 3.47. It doesn't make any sense. Number of errors in the book, either 5 errors, 3 errors, or no error, right? So it is going to be a complete integer or the complete integer. It cannot be any fraction. So this kind of data comes under what is called a discrete measurement data. And what is a continuous measurement data? Continuous means it is capable of taking all values within certain specified range. For example, height can be put into decimals, weight can be put into decimals, or any other measurements can be put into decimals. So this is what we mean by discrete and continuous. So hopefully terminology is clear to about the discrete and continuous. And as far as now, so far I discussed that there is a categorical data and there is a measurement data. Now, knowledge about these scales is very, very important in statistics because many of the softwares, particularly R, SPSS, Minitab, they will ask you, your data belongs to which kind of scale. So these scales have to be very clear. So I'll just take 2-3 minutes to explain you all these scales, and then I'll move on to my main topic of correlation and regression. Don't worry, I'll give you a practical example. I'll solve here and give you each and everything if you are attentive enough. So as I mentioned that there is a categorical data and measurement data, there are 2 scales for categorical data. Please remember, there are 2 scales for categorical data, and these scales are called nominal and ordinal. And there are 2 other scales for measurement data, and these are called interval and ratio. Interval and ratio. All right. Now, first of all, I'll explain you the categorical data scales. Categorical data means like gender, like socioeconomic class, or you can say religion. All this is the categorical data. Or severity of disease, mild, moderate, severe. So this can be put into two different scales. One is nominal, another is ordinal. Now, what do you mean by nominal scale? Nominal scale means there is no preference of one category over the other. Bottom line is if all the categories are given equal weightage. Let me just repeat. If all the categories are given equal weightage, then we say that our data belongs to the nominal scale. For example, gender. Everybody is human being. I can write male as 1, female as 2, or you can write female as 1, male as 2. Doesn't make any difference. You cannot order the categories that this will come first or this will come later. So bottom line is if all the categories are given equal weightage, then we say that our data belongs to the nominal scale. Examples like gender, examples like religion. Everybody is human being. I can write Hindu as 1, Muslim as 2, Sikh as 3, Christian as 4, or you can write Christian as 1, Hindu as 2, Muslim as 3, Sikh as 4. Doesn't make any difference because everybody is human being. All the categories are given equal weightage. So hopefully the idea about the nominal scale is clear to you. Then again, for the second type of scale for categorical data is ordinal. And the difference between nominal and ordinal is that in case of ordinal, the data can be arranged. It's a categorical data, but data can be arranged from the lowest to the highest or ascending or descending order of magnitude. For example, look at education categories. Primary school, say 1, middle school 2, high school 3, graduate 4, postgraduate 5. So all these categories can be arranged in order from the lowest to the highest. Similarly, severity of disease, mild, moderate, severe. I can write 1, 2, 3. 1 means the lower, 3 means the higher, right? Similarly, you must have heard questions like that strongly disagree to strongly agree, very unhappy to very happy. So all this type of 5-point Likert scale, 7-point Likert scale, or a cementing scale, all this kind of data comes under what is called ordinal scale, where you can arrange the categories in order, right? So that's the only basic difference between nominal and ordinal. It is not possible to arrange the data in nominal in a sequence, but it is possible to arrange in ordinal scale. But whether you are dealing with the nominal scale or you are dealing with the ordinal scale, please remember the numerical distance between any two categories doesn't have any significance at all. This is very important. For example, if I'm writing male as 1, female as 2, and subtract 2 minus 1, it doesn't have any meaning. Let's say lower class as 1, middle class as 2, upper class as 3. Subtract 3 minus 1 or 3 minus 2. It doesn't have any meaning at all. So remember, whenever we deal with the categorical type of data scales, the numerical distance between any two categories doesn't have any significance at all. That's all about the nominal and ordinal scale, which comes under categorical data. Now I'll move on to another two different scales, which comes for the measurement data. Measurement data is also having two different scales. One is called interval scale, another is called ratio scale. And people get confused between interval and ratio scale. Let me just clarify with some examples. What do you mean by interval scale? It's a measurement data. For example, let's say beauty score, intelligence score, they all temperature, etc. They all come under interval scale. Why? Let me just explain you. Let's say some beauty contest is going on, and there are judges, say giving score out of 10, right? Let's say first person gets a score of 8 out of 10, and second one gets a score of 4 out of 10. Let me just repeat. First one gets a score of 8 out of 10. Second person gets a score of 4 out of 10. And if you divide 8 by 4, answer is 2. But I cannot make a statement that the person whose score is 8 is exactly twice the beautiful than the person whose score is 4. It doesn't make any sense. Hopefully you understand what I'm saying. So remember, whenever we deal with the interval scale, sometimes the mathematical operations are not valid at all. Let me give you another example. Let's say one student has scored 90 marks in a test. Another has scored 30 marks in a test. Divide 90 by 30. Answer will be 3. But I cannot make a statement that the student whose score is 90 is exactly 3 times the intelligent than the student whose score is 30. You cannot make such type of statement. The person having scored 30 may be intelligence in sports or in other category, right? So remember, whenever we deal with the interval scale, the mathematical operations sometimes are not valid, particularly division, multiplication, etc. That doesn't make any sense. And moreover, in interval scale, 0 doesn't mean the absence of character. 0 has a meaning in interval scale. For example, somebody has scored, let's say, 0 in a test. It doesn't mean the person is not intelligent at all. Maybe on a particular day, his or her performance is not up to the mark. Next time, he or she can score better. Hopefully, you will agree with me. Similarly, look at temperature. If I say temperature 0, it doesn't mean the temperature is absent. It is still better than -5. So remember, whenever we talk about the interval scale, 0 has a meaning. The 0 means quantity or a character exists even at 0. That's why in interval scale, 0 is not counted as a true 0. It is called arbitrary 0. It's called an arbitrary 0, right? There are problems with each and every scale. To overcome all such difficulties, there is a highest rating scale, and that is called the ratio scale. That is the last scale which I explain you before I move on to my main topic of correlation and regression. Now, in ratio scale, all mathematical operations are valid, but you have to be careful about 0. If 0 occurs, that means the quantity does not exist, right? For example, let's say one person is having weight 90 kg, another is having weight 45 kg. Divide 90 by 45, answer is 2. But I can always make a statement that the person whose weight is 90 kg is double the weight of the person whose weight is 45 kg. Nothing wrong with that. But if you come across 0, let's say if I say weight 0, it means it doesn't exist. If I say height 0, it doesn't exist. If I say age 0, it doesn't exist, right? So you have to distinguish between interval and ratio scale, just look at 0. If 0 has a meaning for your variable, your data will go to the interval scale. If 0 doesn't have any meaning, it will go to the ratio scale. As simple as that. Hopefully, idea about all these scales I have explained you. There are 2 scales for categorical data, nominal and ordinal. There are 2 scales for measurement data, interval and ratio. With this background, I'll move on to my topic of correlation and regression. Okay, all these are examples of nominal scale. If you look at the examples of nominal scale, like what is your gender, what is your hair color, where do you live, all these are examples of nominal scale. Ordinal scale, as I mentioned, you can arrange the categories in order, like very unhappy to very happy, very unsatisfied to very satisfied. All these categories can be arranged in order. Interval and ratio I have already explained, so I'm just skipping few slides, just moving on to now main topic of correlation and regression. And if you have any question you can put into the chat box. At the end of this session, I'll answer all the questions. So there are 2 terms here. One is correlation, another is regression. Now, what do you mean by correlation? I'll explain you. I'll explain you both the terms. First of all, correlation. Correlation just give you a strength of relationship between 2 variables or sometimes more than 2 variables. Let me just explain it once more. Correlation just give you a strength of relationship between 2 variables or sometimes more than 2 variables. If it is between 2 variables, let's say height and weight, age and blood pressure, then this type of correlation is called simple correlation. If it is more than 2 variables, then this type of correlation becomes multiple correlation coefficient, right? Now, I'm explaining you a very important point. Correlation is never used for prediction. Very strong statement. Correlation is never used for prediction. Correlation just form a part of prediction. That's all. It's a regression which is used for prediction. You are watching television. There is next day's forecast. Chances of rain this much. Chances of thunderstorm this much. Humidity this much. All they are based on regression techniques. Of course, correlation just form a part of it. But remember, all prediction techniques, they are basically based on regression techniques. Correlation just giving you a strength of relationship. Now, how many different type of correlations are there? So first, I will discuss about correlation, and then I'll move on to regression. And I'll explain you practically also that how to solve the problems. And I'll explain you through SPSS. I can explain you through R also, because time is too short here. And because we have to finish in 1 hour. So I'll be taking the help of SPSS software and give you how to compute different type of correlations. All right. First of all, correlation. So, yes, please. Any question? Anything? Anybody want to ask? Should I move on now? Yes, please. Okay. All right. All right. So there are different type of correlations. Now I'll just explain you. Yeah, hand is there. Thank you very much. Okay. So there are different type of correlations. I'll explain you where to use which type of correlation and where. I'll discuss some correlations which are given in the books. And I'll also discuss some correlations which are not given in the books. Please. Right. And people from medical sciences, people from biological sciences, they always make a mistake. And hopefully, if you listen to me carefully, you will not face any difficulty in computing different type of correlations. First of all, the simplest type of correlation is called Karl-Pearson's correlation coefficient. People from psychology, people from social sciences, they also call this as product movement correlation coefficient. But meaning is same. Either you call this as product movement correlation coefficient or you call this as Karl-Pearson correlation coefficient. It is denoted by small r and its value lies between -1 to +1. Always its value formula is such that its value lies between -1 to +1. And it is applicable to the situation when there are only two variables. When there are only two variables. For example, relationship between height and weight, relationship between age and blood pressure, relationship between income and expenditure. So all this kind of data you can analyze with the help of what is called Karl-Pearson's correlation coefficient. But the important point is where to use Karl-Pearson correlation coefficient. If you are keeping, if you are writing notes, please write down Karl-Pearson correlation coefficient is applicable to the situation under two important conditions. Number one, both x and y, they should be metric variables. That means they should be measurable quantities. If any one of them is categorical, which I have already explained, what do you mean by categorical, like gender or socioeconomic class, please do not compute Karl-Pearson's correlation coefficient. Karl-Pearson correlation coefficient is applicable to the situation when number one, both y and x, they are measurable quantities. Like height is measurable, weight is measurable, age is measurable, blood pressure is measurable. So if you have come across such type of two variables, then you can go for Karl-Pearson type of correlation. That is first condition. Second condition, if you plot one variable along x-axis, another variable along y-axis, and there is a linear relationship. What do you mean by linear? Linear means if points are along a straight line. If you look at the scatter plot, hopefully everybody knows scatter plot. I'll draw also. If you look at the scatter plot and the points are along a straight line, either increasing or decreasing, right? It should not be along a curve that first it will increase, then decrease, and then again increase, something like that. If that is there, you cannot apply Karl-Pearson's correlation. So Karl-Pearson correlation has a limitation that it is applicable to the situation only when both y and x, both the variables, they are linear, having a linear relationship. That means points are along a straight line. So under these two conditions, we can compute Karl-Pearson's correlation coefficient. If your value is coming out to be negative, so their variables are negatively correlated. That means one variable is increasing, another is decreasing. If positive, then one variable is increasing, other is also increasing, right? And if it is close to zero, that means if one variable is increased, there is hardly effect on the other variable. So that's why closer to zero. So that's all about the Karl-Pearson's correlation coefficient. Then we move on to Spearman's rank correlation coefficient. As I mentioned, it's a ranking. That's why the name comes rank. Spearman's rank correlation. It is denoted by rho, this symbol. This symbol is called rho, R-H-O. R-H-O, right? Now, where to compute Spearman's rank correlation coefficient? Please remember, as I mentioned, whenever their ranking is there, for example, your one variable, which is x, strongly disagree to strongly agree. Another variable is also strongly, very unsatisfied to very satisfied, or strongly disagree to strongly agree. Or let's say there are judges who are giving score out of 10. There are 10 participants. Somebody will get rank 1, somebody get rank 2, somebody get rank 3. This is given by judge 1. and similarly by judge 2. Now, these two judges, their judgment may differ. Somebody can give the fifth number participant as rank 1, but the other one can give this as rank as 7. It can happen. So even such type of data, you can use Spearman's rank correlation. So Spearman's rank correlation is applicable to the situation when the data is given in the form of ranks. Hopefully you understand. Second important point. If your data is not normal, hopefully you have gone through the course of parametric and non-parametric tests. You know how to check the normality of the data. Let's say I plot the histogram for X, I plot the histogram for Y, and one of the histogram is not symmetrical. It's non-normal. Even then, please do not compute Karl-Pearson correlation coefficient. You must compute Spearman's rank correlation for non-normal data. Although it's a measurement kind of data, it's not in the form of ranks. It could be a metric variable, measurement variable, but if data is non-normal, it's not normal, it's better to compute Spearman's rank correlation rather than Karl-Pearson's correlation coefficient. Again, the interpretation is same, value lies between -1 to +1. So these are the two important correlations which are given in many of the books. Then there is multiple correlation. Now, multiple correlation is applicable to the situation. Multiple correlation is applicable to the situation whenever there is one variable and it is dependent upon so many other variables. For example, let's say yield of a crop. Yield of a crop depends upon many factors. It may depends upon, let's say, amount of fertilizer used, amount of seed used, amount of rainfall, amount of soil fertility, and so on. Why is your yield? So yield depends upon so many other factors. Similarly, blood pressure. Blood pressure may depend upon age of the person. It may depend upon body surface area. It may depend upon some other parameters also. So if such type of situation is there, then we can compute what is called multiple correlation coefficient, right? But the important point to note under multiple correlation coefficient is that all these should be measurable quantities. For example, Y is a measurable quantity. X1, X2, Xk, they are all measurable quantities. They are all measurable. They cannot be categorical variable. That's why I explained you categorical variability in the beginning. If any one of them is like gender or socioeconomic class, you cannot compute multiple correlation in that situation. All Y, X1, X2, Xk, they all have to be metric variable. Metric variable means they all have to be measurement. That is the biggest restriction in multiple correlation coefficient. Remember this, right? And then also remember that it's a square. Square can never be negative. Square can never be negative. So multiple correlation coefficient always lies between 0 and 1. 0 and 1, right? If it is closer to 0, very poor type of correlation. If it is closer to 1, high correlation between Y and all the X1, X2, and X. So this is what we mean by multiple correlation coefficient. Then there is partial correlation coefficient. Partial correlation, many of the people, they ignore this correlation, but it is very important correlation, particularly in medical sciences. Let me give you an example. For example, somebody give me this task that you have to find out the correlation between age and blood pressure. Okay. Now, if I plot age along x-axis, blood pressure along y-axis, points are along a straight line. So I'll simply compute Karl-Pearson's correlation coefficient. Nothing wrong with that. But somebody can ask me this question, that whether there were smokers and non-smokers were also in your data. Now I have completely ignored this aspect. And clinically, those who are from medical sciences, they can very well understand that clinically it is well known fact, it's clinically tested that those who are smokers for a long time, they are likely to have high blood pressure than those who are non-smokers, right? Now, whatever the relationship you are getting between age and blood pressure, that could be the effect of smoking only. You are not getting the exact relationship. So what does this mean? This means that there is third variable which is indirectly impacting the relationship between the two variables, age and blood pressure. So in such type of situation, we use what is called partial correlation. Partial correlation means correlation again between two variables, but to find out the exact relationship between age and blood pressure, I need to control the effect of smoking. So if you control the effect of smoking, then we say that we have to go for a partial correlation coefficient. So symbol used is 1, 2.3. 1, 2 means correlation between variable x1 and x2 by keeping x3 as controlled variable. This is what it means. You can control two variables also, right? No problem. Okay. Now, it is not necessary that points are always going to be along a straight line, either increasing, decreasing. If points are along a curve, first increase, then decreasing, right? If they are along a curve, then you can go for another type of correlation, which is studied with the help of what is called correlation ratio. It is denoted by eta square. Again, value lies between 0 to 1. And if there is a curve type of relationship, polynomial, cubic, etc. relationship, they are known as curvilinear relationship. We studied with the help of what is called correlation ratio. Then sometimes if you look at the relationship between some variables, there is no relationship. I mean, you cannot say that points are increasing, points are decreasing. Even there is no curve also. Then such type of, you can only rule out the possibility that there is no curvilinear relationship, there is no linear relationship, but there could be any other relationship which is not specific. And those type of correlations are studied with the help of what is called non-linear correlations, which is beyond the scope of this certificate program. So I'll not discuss those, but I'll give you examples. Look at this diagram. If I'm plotting height along x-axis, weight along y-axis, so you can see points are along a straight line, increasing. So you can immediately see you will apply Karl-Pearson's correlation coefficient, right? Similarly, prices are increasing, consumption is going down. So that's why there is a scatter plot, but decreasing trend. So correlation will be negative in this case, correlation will be positive in this case. So this is how we can think of that. We can apply Karl-Pearson's correlation coefficient. Look at this picture. Correlation between blood pressure and hemoglobin. I'm writing blood pressure here and hemoglobin. There is no trend here. There is no trend, no curve looks like. So you can only rule out the possibility that there is no linear relationship or there is no curve type of relationship, exactly curve type of relationship, but there could be some other type of relationship which is not visible. And this is the situation where we have to go for the non-linear correlations, which is beyond the scope of this program. Okay. Now, it's not the only the correlations which I have discussed. There are different other type of correlations. And as I came to know that there are people from medical sciences here, because I am involved with medical sciences. I am working with NIH, which is called National Institute of Health in US. And we are looking into different type of advanced cancer prediction techniques and finding out the genetic association between the disease and the nucleotides and the different types of SNPs. So that kind of work we are doing through the statistical modeling. But there are different type of correlations which we are using. So if you remember, I discussed right in the beginning about the categorical data scales, nominal and ordinal. I discussed about the measurement scale, interval and ratio. Now, let's say your one variable is nominal, another is also nominal. Then which type of correlation you are going to compute? The previous correlation which I discussed, Karl-Pearson, Spearman's, rank, nothing is going to work. Nothing, no correlation is going to work. And people get confused. They generally compute chi-square. People from medical biological sciences, they compute chi-square. But remember, chi-square always give you a positive value. Chi-square always give you a positive value. You will never come to know whether your association is negative or positive. So that's why I'm discussing some important correlations. If there is nominal by nominal, that's one variable is nominal, what could be the examples? Let me give you example side by side. Let's say one variable is gender, which is nominal. Another is blood types, O positive, A negative. All these are also nominal scale. So you are looking at the association between the blood types and gender. So which type of correlations to be computed? So this is I have listed: contingency coefficient, phi and Kramer's V, lambda and uncertainty. Out of this, uncertainty coefficient is the best one. This is the best coefficient to be computed if there is nominal by nominal data. If there is ordinal by ordinal data, ordinal means one variable is ordinal, another is also ordinal. For example, let's say very unsatisfied to very satisfied, one variable. Another is also very unsatisfied to very satisfied, right? Ordinal by ordinal. Then which correlations to be computed? Gamma coefficient you can compute Somers-D, Kendall-Stowe, but out of this gamma is the best for ordinal because it is based on concordant and discordant pair. It will give you a negative and positive value. So if gamma is coming out to be negative, there will be negative association. If gamma is positive, there will be positive association. Of course, when you are having one variable as nominal, another as ordinal. For example, one nominal variable is gender, and the ordinal variable is socioeconomic class, lower class, middle class, upper class. So one variable is nominal, another is ordinal. You can go for chi-square, no problem in this, right? Then there is nominal by interval. One variable is nominal, another is interval. For example, one variable is gender, another is blood pressure. Another is blood pressure. So which type of correlations to be computed? Kappa, risk, McNemar. Out of this, eta is the best coefficient. Let me tell you, eta is the best coefficient if you are dealing nominal by interval. And if you are dealing by the ratio by ratio or interval, that means measurable quantities, you have lot of choices. You can compute Pearson, Spearman, multiple correlation. All these things can be computed. So hopefully I have given you a complete picture where to use which type of correlation. All right. Do not straight away go for chi-square in case of categorical data. So these are the different type of correlations. They are all given in R, they are given in SPSS, they are given in many of the other softwares. Okay. So probably I will share this slide and you will see different examples of nominal gender versus blood types, parental age versus risk of disease, or AMD versus AMD is called age-related macular degeneration, risk of disease, and all these RNA-seq generating gene expression and profiling and all this. Okay. Now, what is the idea of linear relationship? For example, look at the left-hand side. Points are along a straight line. Points are along a straight line. So they are linearly related. This is what do you mean by linear? So you can go for Pearson. But look at this thing. This is along a curve. This is also along a curve. So this is using curvilinear relationship. This is using linear relationship. Now, what is the idea of strong and weak relationship? Strong relationship means points are very close to each other. Points are very, very close to each other. That's the idea of strong relationship. What is the idea of weak relationship? Weak relationship means points are, although it's increasing, this is decreasing, but points are not close to each other. Here, if you compute the correlation may be 0.5, 0.6. And here, if you look at the correlation, maybe 0.8, 0.9. So that means it's a strong relationship, it's a weak relationship, right? Okay. So I have all the Pearson, partial correlations, Spearman's, so multiple correlation, all these things. Now I'll move on to regression before giving you the practical exam. Okay. Now, as I mentioned right in the beginning, regression is used for prediction. Regression is used for prediction. So first of all, there are two types of regression. One is called simple regression. Simple regression, just like simple correlation, involves only two variables, where one is called dependent variable, another is called independent variable. For example, here y is a dependent variable, x is an independent variable, and this is called an error. Now, if I don't include this error, this is the equation of a straight line, which you have learned in your 10th standard. Y is equal to mx plus c. If you just forget about epsilon I, it is mx, where m is your beta 1, x is this, and c is your this. So y is equal to mx plus c. It's the equation of a straight line. Now, what is a simple linear regression? Simple regression in linear regression involves only two variables. One variable is called dependent, another is called independent. For example, a relationship between, let's say your dependent variable is time since death, and your independent variable is sodium potassium ratio. So you have a sodium potassium ratio and you have time since death, and you want to see whether if the sodium potassium ratio is increasing or decreasing, whether the time since death is, how you can estimate the time since death. How you can estimate the time since death. It's a very useful technique, right? All right. Similarly, let's say I want to estimate weight for a given height. So y is your weight, x is your height. Now there are two unknown coefficients. Epsilon is error. This error is basically error in measurements. I'll explain you what is the meaning of this error. Because models are not give you 100% correct answer. For example, if somebody predicts that there are chances of rain tomorrow between 11 to 11:15. Now, it is not necessary that rain will exactly come between 11 to 11:15. It may come at 11:20. It may come at 11:30. So there are always chances of error. These are called errors in measurements. And whenever we look at the statistical models, we always include this error. The smaller the error, better will be result. So we have to minimize this error statistically. How to minimize this error? So there is a mathematical formula which is called method of least square. We minimize the error sum of squares and we estimate these coefficients, which is called beta naught and beta 1. Now, if I and epsilon will go to 0. Suppose I give you value of this beta naught as say 3.4, value of beta 1 as say 9.4. Then you give any value to x, you can estimate y. So that is called prediction. You can, for any value of x, you can predict y. So that's why called simple linear regression. So this is what do you mean by the entire thing. So this is called intercept. This is called slope. This is independent variable. This is a random error, which is beyond your control. And this is your dependent variable. Dependent variable, right? So picture will look like this. For example, if your point is x, this is scatter plot. This is scatter plot. You can see 5, 6 dots. This is scatter plot. Now, what is this beta naught? This is called regression line, which I'll write today practically. This is called regression line, right? And at what point this regression line is going to cross this y-axis, this is y-axis, the distance from origin to this point, the distance from origin to this point is called intercept. So this is beta naught. And what is beta 1? If you drop a line, draw a line parallel to x-axis, then this angle which is being formed, this angle, which is theta, let's say, this is called slope. So if your line is more steep, this slope will be high. If line is flatter, slope will be less. So line depends upon two things. One is intercept, another is slope, right? And this can be estimated from the given data. This can be estimated from the given data. So today I'll show you how to estimate this. And once we estimate by using this method of least squares, you will get the estimate of beta naught, you will get the estimate of beta 1. Suppose from the given data, let's say I'm given weight, I'm given height of 30 people. And based on this 30 pairs of observations, I'll estimate this beta naught and beta 1. I'll show you how to estimate. And once you estimate, picture will look like this. This is an estimate of beta naught. This is an estimate of beta 1. Now, these values are known to you from the given data. Now you give any value to x. Let's say x height is 157.5 centimeter, then what is the corresponding weight? So these values are known. So you multiply this with the slope plus add the intercept, you will get the answer, right? So this is how we can estimate this value. So very simple, which is called simple linear regression. Now I'll go to multiple linear regression. The multiple linear regression is an extension of simple to multiple. In simple regression, there are only two variables. One variable is dependent, another is independent. But independent variable may be more, just like yield of a crop. Yield of a crop may depend upon y, say depend upon amount of rainfall, amount of fertilizer, amount of seed used, soil fertility, and so on. So this is multiple regression. Multiple regression is there is one dependent variable and there are k number of independent variables. So if you stop here, it's a simple linear regression, beta naught plus beta 1 x1. But if you include k number of variables, x1, x2, xk, and there are some errors in measurements again, this error will go to 0 once we estimate. So again, we apply the method of least squares. And once we apply the method of least squares, you will get the estimated value. And this will be given you estimated from the given data. This value will be known to you, beta 1, beta naught will be known to you, beta 1 will also be known to you, beta k will also be known to you. Now you give any value to x1, x2, xk, you can estimate y. And these are estimated using the method of least squares from the given data. Now here, some very important point. Please try to understand whenever we do multiple regression. Suppose there is one variable which is y, dependent variable. It may depend upon k number of factors. Now, do you think all the k will be important to predict this y? Not necessary. Maybe out of the k variable, only 4 are important or only 5 are important. And I need to identify that. Number one. Number two, which is the most important variable which can predict y? Which comes at number 2? Which comes at number 3? This is also equally important, right? An answer to these questions are given by what is called stepwise regression. So if you apply stepwise regression, basically while we are applying stepwise regression, the variable which is coming at number 1, this is the most important variable to predict y, will come at number 1, next will come at number 2, next will come at number 3, and if only 4 variables are important, rest of the variables will be out of the model, that they are not important. So this is what do you mean by multiple regression. All right. So now I'll give you a practical demo. So I'll be taking 15 minutes to give you a practical demo, then I'll stop. Before coming to this, let me show you one picture. There is a line A, there is line B. Dr. Amit Tiwari, are you there?
Yes, yes, sir. Yes, sir.
Yeah, very good, very good. So I'm just asking this question because I think others are muted. So if you see from your eye,
all are allowed to unmute. All delegates
Oh.
are allowed to unmute at their end. I allowed
oh, very
everyone.
good, very good, very good. So if I ask these questions, if you see from your eye, line A looks smaller or line B looks smaller? Yes, please. And can anybody answer?
So B.
Line B is smaller
Sorry,
or A?
sorry, A is smaller.
A is smaller. Okay, okay. Right. You are absolutely right. But let's test your knowledge also. Okay. Let me go through this. Let me go through this. So A and B both are same virtually. Both are same. But if you see from here, A looks smaller and B looks bigger. You agree with me, madam?
Yes, sir. Yes, sir.
Now, what is the reason? Reason is here simple, because A is closed from the both sides. Is that okay? While B is open from the both sides.
Definitely.
Right? So I'll just explain you what I'm trying to say. If you are listening to me with open mind, you are looking at line B, basically. If you are listening to me with closed mind, it's the same thing which I'm explaining, but you are looking at line A. So I request you to listen to me with open mind so that you can understand the things better. Right? This is
Yes,
what I
sir.
wanted to tell you. और मैं बहुत से लोगों को बताता हूँ कि जो लोग क्लोज माइंड के होते हैं उनको जिंदगी बहुत छोटी दिखाई देती है, और जो लोग ओपन माइंड के होते हैं वही सेम जिंदगी बहुत बड़ी दिखाई देती है. मेरी बात समझ में आ गई मैडम? ऑल राइट.
Yes, sir.
तो ये and this completes your theoretical part, and there are many softwares. So these are some of the references which I'll send you this PPT. Hopefully you can understand. Now go through the practical example. So I'll move on to the practical examples. Please wait for a moment. First, I'll go for simple linear regression and then for multiple. It won't take more than 15 minutes. Don't worry. All right. Anybody want to ask some questions? The file is just opening. Anybody want to ask some question? They can unmute and they can, yeah, unmute and ask me. All right. Should I continue? Yes, please, Dr. Amit.
Yes, yes, please. Continue.
Can you see this SPSS sheet?
Yes.
Yes, sir.
Yeah. All right. I generally conduct 3 to 4 days of workshop for covering all the topics of statistics, all the topics, right from the beginning till end, right from the basics of statistics to ANCOVA, MANOVA. Since I don't have a time to explain you all this, you can go through my YouTube videos. If you simply write down statistical techniques using SPSS by Suresh Sharma, many videos will open and you can learn factor analysis, you can learn cluster analysis using R as well as SPSS. You can go through the MOS program also, which I have. All these are free, which are there on the YouTube. All right. Okay, you can open the Beyond Boundaries also YouTube and see all these videos. All right. So here is a practical real life example from medical sciences. I am working into medical sciences and many people are here from medical sciences. You see, There is a birth weight and there is gestation. And everybody knows that birth weight depends upon the gestation age of the mother. And there is some kind of relationship between, not some kind, it's definitely a relationship between birth weight and gestation, right? Obviously, if it's a normal gestation period, which is 37 to 41 weeks, you can expect a normal birth weight. But if it is a premature baby, which is called pre-gestation period, and then obviously there will be birth weight will be low. There are many complications to the baby. So first of all, I'll go through the correlation and then I'll go for regression. So first of all, look at the scatter plot. So go to graph, go to legacy dialog, and go to scatter plot. I just want to see, is there any relationship between birth weight and gestation? So this is a simple scatter plot. Define, and let's say I take birth weight, whatever you want to predict. We basically want to predict birth weight based on gestation. So birth weight depends upon gestation. Please remember, gestation doesn't depend upon birth weight. So birth weight you always take on a y axis. Whatever you want to predict, that is always goes to the y axis, and independent variable goes to the x axis, gestational age. So look at the scatter plot. So this is the picture of a scatter plot. Okay, can you see this picture, madam? Hello? Can you see this picture?
Yes, sir.
Yes, sir.
Yeah. All right. So you can see points are increasing. So you can go for Karl-Pearson type of correlation. No problem with that, right? We can, so with the help of scatter plot, I come to know that I can go for Karl-Pearson's correlation coefficient. So scatter plot give you some idea. If this would have been curvilinear, don't go for Karl-Pearson correlation coefficient. Particularly if I remove these points, the points are increasing. Which type of correlation you can expect? Yes, please. Anybody? Which type of correlation you can expect increase point in positive or negative?
Positive, sir.
Positive. Very nice. Very nice. So you are understanding. So positive correlation is expected. Let's look at the amount of correlation. How to compute this correlation? Go to analysis, go to correlate, and go to bivariate. Why bivariate? Because there are only two variables. And take both the variables on this side. And this is Karl-Pearson correlation coefficient. If you are interested into Spearman, you can click on to Spearman. If you are interested into Candle-Straw, you can go for Candle-Straw, which is generally used for agreement. But since Karl-Pearson is okay for me, so I'll go through and then explain you the output. So simply take these two variables on this side and go for Karl-Pearson's correlation coefficient. So just computing this. Okay. So it will give you a correlation matrix. Hopefully you understand what do you mean by matrix, because there are two variables. So there will be two rows and two columns. These are the two rows. First row, second row, two columns. First column, second column. First, it will give you a correlation between gestational age and gestational age. So obviously same variable will be 100% correlated with the same variable. So correlation is 1. That is not our interest. Similarly, birth weight with birth weight will be 1. So diagonal will be 1, 1. No problem. But that is not our aim. Our aim is to find out correlation between gestational age and birth weight. So this is a correlation. Gestational age and birth weight. How much is the correlation? Yes, please. 0.818. Obviously, it is a positive. Value has to be between 0 and 1. So it's a positive correlation. So you can see, we can say that there is a positive correlation between gestational age and birth weight. If gestational age is increasing, birth weight is also increasing. The second value is your p-value basically. Wherever in SPSS it is written significance, that means it is a p-value. So your p-value is how much? 0.000. And for the time being, hopefully somebody must have explained you the meaning of p-value. If p-value is less than 0.05, please remember, if the p-value is less than 0.05, the correlation is significant. So obviously, please remember, p-value is never 0. P-value is never 0. I can prove it here only. Let me see. If you double click here and look at this, go to its cell properties. And in cell properties, I'll go to format values. I'll go to number, because SPSS give you 3 decimals. Let me take 13 decimals and it will give you certain p-value. So this is actually the p-value. So p-value is never 0. It's not written in any book, please. Right? So if there is 3 zeros, always write down 0.0001. You always put 1 if there are 3 zeros, because p value is never 0. All right. So now why it is called product movement correlation? Because whether you compute correlation between gestational age and birth weight, or you compute between birth weight and gestational age, correlation is same. So that's why whether you multiply 3 with 4, you will get answer as 12, or you multiply 4 with 3, answer will be 12. So that's why sometimes this is called product movement correlation, and 17 observations are involved. So this is the interpretation. Hopefully it's clear to you. Now we'll go for regression. First of all, simple regression, and then in the last 5-6 minutes, I'll go for multiple regression. So now go to regression. Analysis, regression, go to linear again. Your dependent variable is birth weight, independent variable is gestational age, and simply press OK. Simply press OK, and you will get the answer. So this is again the same value of R which we have, 0.818. We have seen already this 0.818. So it's already there. Now, if you are using a simple regression, R square doesn't make much of the sense. You have to see only R, right? And I'll explain you what is this ANOVA table. But first of all, look at how these values have been estimated. Your model was y is equal to beta naught plus beta 1 x. Now, what is your beta naught? So let me write down the equation here. Let me write down the equation here. So this is your birth weight. So your birth weight will be equal to beta naught. Your beta naught is this value. Beta 1 is this value. So now I'll write down minus 4,020.054 plus 180.455 multiply with gestational age. Gestational age, I'll write GA. So this is the equation you are getting, right? So this is your value of beta naught. This is the value of beta 1. Their value have been estimated from the given data. And now you give any value. For example, if somebody says, if gestational age would have been 29, what could have been the birth weight? So you just multiply 29 with 180.44, subtract this, and you will get your birth weight. Hopefully you understand what I'm saying. Is that clear, madam? Hello?
Yes, sir. Yes, sir.
Right? So this is the equation you are getting. Now, if you remember, in our equation, the y is equal to beta naught plus beta 1 x. What is this ANOVA table? ANOVA table value, this is a p value. Again, this is a 30. So you have to write down p value as 0.0001, because p value is never 0, right? So what you need to report if you are using simple regression, you need to report the value of R. You need to report this equation, and also value of this ANOVA table. What this ANOVA table is? This ANOVA table is basically testing. It's not one-way and two-way ANOVA. Forget about this. This ANOVA table is basically testing your slope, whether your slope is significant or not, right? For example, what is slope? Beta 1. So it is testing the hypothesis H0 that beta 1 is 0. Against that, beta 1 is not equal to 0. Now, if I accept the hypothesis that beta 1 is 0, then y will depend only on beta naught, which is intercept. So if you change x, now beta 1 into x, now beta 1 is 0. If I accept h0, x will not affect the value of y. So that's why this value has to be significant. So ANOVA table value must be significant. Remember, ANOVA table value must be significant. R should be significant, and this is the equation which you need. So you do all the things, then you are through. And you can, if you want to see graphically also, you can plot a regression line. You double click here, and if you double click, you will come to what is called chart editor. That means you can edit your chart, place your cursor at any point. You can see a yellow border around this, and then right click at any point and write fit line at total. So you will get the regression line. So this is the regression line actually. Line of best fit. Line of best fit. So if you want to show graphically, you can show this also. So this is the line of best fit. So this is how you can interpret this with R, a simple regression. Now, finally, I'll move on to multiple regression. Can I take 5-6 more minutes to explain you multiple regression? Yes, please.
Yes, sir. Please take your time. There is no bar, sir. Please take your time, sir. No problem.
Okay. All right. All right. So move on to डॉक्टर अमित तिवारी.
Yes, yes.
अगर कहो तो पार्टिसिपेंट्स को एक शेर सुना दिया जाए क्योंकि बोर हो रहे हैं लगता है.
Definitely, sir.
नहीं,
Definitely.
क्योंकि मैं अपने शेर भी खुद लिखता हूँ. चलो एक शेर
Definitely,
सुना
sir.
देते
I
हैं.
also write poetries.
ओह वेरी गुड वेरी गुड.
Yes, sir.
चलो पार्टिसिपेंट्स के लिए एक शेर. कि
Definitely.
खूबसूरत सा एक पल किस्सा बन जाता है. खूबसूरत सा एक पल किस्सा बन जाता है. ना जाने कौन कहां जिंदगी का हिस्सा बन जाता है. कुछ खास लोग यानी हमारे पार्टिसिपेंट्स की तरह कुछ खास लोग मिलते हैं जिंदगी में इस तरह जिनसे ना कभी बिछड़ने वाला रिश्ता बन जाता है.
बहुत
वाह
खूब सर.
वाह सर, बहुत अच्छा सर.
चलिए
बहुत खूब.
सो वी विल मूव. और एंड में आपको लास्ट में दो तीन और शेयर सुना देंगे. लेकिन उससे पहले काम खत्म कर लें. लेट्स मूव ऑन टू कोरिलेशन, मल्टीपल कोरिलेशन. So I'll move on to multiple correlation. So this is multiple. Just wait for a moment. All right. So here is the data. Hopefully you can see this data.
Yes.
Yeah. Okay. So here is an important point. Somebody wants to estimate IQ. So IQ is a dependent variable. It's a data from psychology department from our university. Some student came to me and she was a psychologist, and then we come that it's a multiple regression problem. She wanted to estimate IQ based on certain parameters like x1, x2, xk. So mental age, one parameter, that is your x1. Anxiety, x2. Depression score, x3. Stress, x4. Communication score, x5. And convolution score, x6. So here y, which is IQ, is a dependent variable, and it depends upon x1, x2, x3, x4, x5, and x6. So these are all independent variables. Hopefully you understand. If I stop here IQ and mental age, then it's a simple regression. But now y depends upon 6 predictors. These are called predictors. Now the important question is, this is based on their judgment. They want to predict based on IQ, based on this 6 predictors. There could be other predictors also. Now, out of these 6 predictors, they wanted to know which is the most important predictor which can predict IQ, number 1. Which comes at number 2, which comes at number 3. Now, do you think all of them are going to be important? May not be. Only few of them may be important, or none of them may be important. So it's a problem of multiple regression. So how to solve this problem? Go to analysis, go to regression, go to linear again. Can you tell me which one is your dependent variable? Yes, please. Yes, please. Which one is dependent variable? Hello? Yeah, you can see from your data.
IQ.
IQ, yes. Somebody will. They want to predict IQ. So whatever they want to predict, that will be your dependent variable. So dependent variable is IQ. And rest of them, they are, and they want to predict IQ based on x1, x2, x3, x4, x5, 6 predictors. So these are, just press Control A and shift them to this side. Right? Okay. I'll simply apply the enter method and show you the result. Then I'll refine this model. Now see, if I press OK, you will see this kind of result. It says that value of, in this case, whenever we apply multiple regression, please do not see R. Always see R square. Always see R square and adjusted R square. I'll explain you the meaning of R square, adjusted R square. First of all, what is R square here? 0.996. Very good. And ANOVA table value is also significant. It has to be. Then look at this thing. Here there is whether each variable, which is independent variable, is making a significant contribution to predict IQ or not, is given by its significance level. So look at our dependent variable is IQ. Let's say, what is the first variable here? Mental age. Look at the significance. What is the significance here? Yes, please. 0.0001. That means it is significant, yes or no? Yes, please.
Yes, sir.
So that means obviously mental age is an important variable to predict IQ. Let's look at the second one, anxiety. What is the p-value of anxiety? Again, it is
0.0 significant, sir.
Yeah,
Less than
significant.
0.005. Yeah.
Absolutely, absolutely. What about depression score? 0.03. It is still
Insignificant,
less
sir.
than
No. Significant, sir. Yes.
significant because less than 0.05.
0.05.
0.03
Yeah.
is less than. All right. So this is also significant. What about stress? What about stress?
So it is insignificant. Greater
It
than
is
0.05.
Exactly. What is communication score?
It's also insignificant.
What is convolution score?
Both are insignificant. Yes.
In all the three are significant, right? So this all the three are significant. Now let me go through the correlation matrix also and show you some important point which is not given in any book. So go to correlation and show you something. So this is bivariate. Let me take Control A and shift it here and compute Computation. So here is the important point. If you look at correlation between IQ and mental age, it is significant. Yes, madam, because p-value is less than 0.05.
Yes, sir.
Then correlation between IQ and anxiety is also significant. Correlation between IQ and depression score is also significant. Then correlation between IQ and stress, p-value is more than 0.0, insignificant. Then correlation between IQ and communication score, significant.
Yes.
Now here is the important point. But correlation between communication score and IQ is again insignificant. So if your result is based on correlation, somebody can say that 4 variables are significantly correlated with IQ. So IQ may be predicted based on these 4 variables. It's absolutely wrong interpretation. Absolutely wrong interpretation. Why? Because right in the beginning, I repeated the sentence again and again that correlation is never used for prediction. If you remember my words, that correlation is never used for prediction. It's only the regression is used for prediction, right? So if you give your results based on correlation, it is absolutely wrong. Basically, when you have applied regression, how many variables are coming out to be significant out of the 6? How many are coming out to be significant? 1, 2, 3.
4.
No, 3 here. 3.
Insignificant 3 and significant 4.
What? No. Constant is not. Please do not include constant. Only mental age, anxiety, and depression. Only 3 variables are significant. These 3, not these 3. So out of the 6, how many are significant?
So 3.
3. While correlation says 4.
Yes.
Which doesn't make sense,
Sir,
right?
I have a query. Please.
Yes, please.
Me.
Sure.
Sir, one of my scholar is doing work in between association between nidra, sleep, and mental well-being.
Right.
Sleep and mental well-being. So, so
Right.
there are 2 words. First one is association, and other one is correlation.
Yeah.
And
Let me just explain you.
G.
If you are dealing with categorical data,
Yes,
you are
sir.
dealing with categorical data, we are looking into association measures.
G, sir.
And if you are looking at a measurement data like height, weight, for example, IQ, anxiety, all this is the measurement data. Then we compute correlation.
Sir, actually,
So
in
if you
sleep,
are-
there is categorical data, good sleep or bad sleep. And in the
if it is-
mental well-being, there is the DA scale as you have used here, depression, anxiety, and stress.
So use compute the coefficient of eta coefficient. Then I have already explained you. Eta
Sir,
coefficient.
as I am from the Ayurveda field, so there, sir, we know that if there is good sleep, then the mental well-being will be good. So we should use the word correlation, or is it by the research we are predicting that?
No.
What,
Let me just explain you.
Yeah.
This, please listen to me. I understand your problem very well. Listen to
Ji,
me
sir.
carefully, please. Now, because you can be in contact with me later on also. Don't worry, right?
Sure, sir.
So what I'm trying to say, your problem is basically good sleep or bad sleep, and then there is what is the second variable? I mean,
Sir, mental well-being. There, the
mental
DA
well-being.
scale is used, depression, anxiety, and stress.
Basically, you should look into mental well-being, whether there is any difference. It's not a problem of correlation. Let me tell you, it's a problem is to see the mean difference between the good sleep and the bad sleep, whether it is a significant difference or not, as far as well-being is concerned, right? So you
Yes.
should not look at the correlation problem. You should apply either, if your data is normally distributed, apply t-test. Not distributed, then you go for Mann-Whitney test.
Okay, sir. Okay.
Don't go for correlation.
So, in the
It will
synopsis,
not make
actually,
much
we have
sense.
used the word association. That's why
Yes.
we have used the word association between.
Because at that time you are not knowing this aspect, right? Anyhow, if you have used the association, another way I can tell you, then you take a median of the well-being or mean of the well-being, okay,
Okay, sir.
and divide this into two categories:
Okay, sir.
low well-being and high well-being, and then you will having both of them are categorical variable.
Yes, sir.
One is gender and another will be this, and then you can compute the association. That's another way.
Okay. Okay.
All
Okay,
right, if
sir.
you have used that word. All right.
Thank you, sir.
All right. So now you tell me one thing. If three variables are significant, why unnecessarily we should include the rest of the three which are insignificant? Yes or no? They are not making any significant contribution. What do you think? See, these are non-significant variables. They are not making any significant contribution to predict IQ. Then why they should be retained in the model? They should be out of the model. Yes or no?
Sir, they should be retained.
Why? If something is not making a significant contribution to you, do you want to retain that? If some medicine is not effective at all, you want to give to the patient again and again. This is what I'm saying. It doesn't make any sense. Hopefully others will agree with me. Yes? Hello? Silent हो गए सभी लोग.
We should see for clinical correlation, sir.
Yeah, you can go for a clinical correlation. If clinically it is making an impact, obviously you can think of. But
Yes.
here I am saying from the statistical point of view that out of the 6, only 3 are significant, rest of the 3 are not. So they should not be included as in the part of the model, basically, because they are insignificant. Yes or no?
Yes, sir.
Right?
Yes.
Unless there is strong evidence, clinical strong evidence, then
Yes.
it is fine. Otherwise, not. Okay. Now, how to come out this problem? So we apply what is called stepwise regression. That's why we use stepwise regression. If you use stepwise regression, it will retain only automatically those variables into the model which are making a significant contribution. Rest of them will be out of the model. So how to apply that stepwise, the last step. So, and then I'll stop. Now you look at, and one more important point. In enter method, I have used the enter method. In enter method, the variable which was at number one variable was mental age. You can see the hierarchy: mental age, anxiety, depression. Let me show it to you. Mental age, anxiety, depression, stress. So it's taking that in that order only. You can see it is taking in that order. Is it clear? Hello. It is the same order. Mental age number 1, anxiety number 2. Can you see that?
Yes, sir.
Yes, sir.
Right. But if you apply stepwise, the variable which is the most important to predict IQ will come at number 1. And then next will come at number 2 automatically. And those who are not making significant contribution, they will be thrown out of the model. Now, if you look at the correlation, matrix, which variable is having highest correlation with IQ? Can you tell me out of these where the star is marked? Which variable is having highest? Yes, please. Highest correlation in the first row. Anybody?
Anxiety.
Anxiety.
Yes.
So virtually anxiety should have been come at number 1. What do you think? Yes?
Yes.
So let's see. So I will apply now multiple regression, stepwise regression. So go to analysis, go to regression, go to linear, and then I change this method. There are many methods: stepwise, remove, backward, forward. So whether you apply stepwise or you apply forward, both of them are equally better methods. Whatever you want to apply. So let me apply forward method. Forward means it will retain only those variables into the model which are making a significant contribution. So go to statistics, compute R-square, descriptives, confidence intervals. These 3 things. Then go to plots also. In plots, you can take a dependent variable here and Z predicted value on y-axis. Then in options, you don't require to do anything. That's all. So it is through with the stepwise multiple regression. Press OK, and here is the result. So here is the result. You see. Now, can you see that variables entered or removed? Which variable is our number one? Yes, please. Which variable is at number one now? Anxiety.
Yes.
So anxiety is playing a most important role to predict IQ. Dependent variable is IQ. Next one. Yes, please. Next one. Mental age.
Mental age.
Next one, depression score. And where are the rest of the three? They are out. They have been thrown out of the model.
Yes.
Automatically. Why? Because they were non-significant. Now you can see.
Yes.
How to read this output? Please just to give me 2 minutes, then it is over. Look at model. There are three models. First, 1, 2, 3. You will have to see only the model number 3, not model number 1, because now the model number 1, because it's a stepwise. Model number 1, say A. A include only anxiety, only one variable anxiety. Then B includes anxiety and mental age. And model C includes all the three: anxiety, mental age, and depression. Then it has not gone to model number 4 because others were non-significant. So it stops at that point. So you have to report this value of R square, which is 0.995. Then adjusted R square you also need to report, which is 0.994. I'll tell you the meaning of adjusted R square. Just wait. So R square you need to report at the third step in the final model. Adjusted R square you have to report. And in the final model, again the same picture here. There will be 3 ANOVA. This is ANOVA for model 1, ANOVA for model 2, ANOVA for model 3. You have to see only the last ANOVA model. Its value must be significant. And it is significant. Right. Then from here you have to form an equation. How to form an equation? This include model number 1 include only anxiety. Don't go for this. Model number 2 include anxiety and mental age. Don't go for this. Look at the final model. This is your final model, and double click here and write down your equation like this. So let me write down the equation. IQ is equal to constant. Your constant is here. Minus 13.667 plus this is constant, 0.906 multiply with the corresponding anxiety. Let me write anxiety as AN just to save time, plus 0.702 multiply with the next is mental age. So let me write MA for mental age, plus next is 4.627 multiply with depression score. So let me write DS, depression score. So this is your final equation, right? So here is the equation. Can you see the equation, madam? IQ is equal to this, and this. Anxiety, mental age, depression. Hello?
Yes, sir. Yes, sir.
So what you need to report now, finally, the last step, what you need to report, you have to report the value of number 1, R square 0.995, adjusted R square 0.994. 2 important points. Value of ANOVA table significant. The last step, and this equation, this final equation. And you are through with the multiple regression. Right? So this is what you require here. Now, what is the difference between R square and adjusted R square? Some people only report R square, which is absolutely wrong. You have to report adjusted R square. Now, 4 important points in multiple regression. Please, if you are carrying a pen or pencil, write down, please. Can you write down, madam? 4 important points.
Yes, sir.
Number 1, value of R square must be high. This value of R square at the final step must be high, and it should be significant. And we have seen that it is significant. You can see also here that this value is coming out to be significant. Number 2, there should not be much difference between R square and adjusted R square. there should not, very important point, there should not be much difference between R square and adjusted R square. Here R square is 0.995, adjusted R square is 0.994. So very close. So that means you are moving in the right direction. I'll explain you what is the why I'm saying this. Right. Third, a NOVA table value must be significant. And the fourth important, all these coefficients, anxiety coefficient, you see this p value must be significant, mental age significant, depression score significant. They should be significant, and you write down this equation. So these are the four important points. Let me explain you what is the difference between R square and adjusted R square, and why it is important to report. Final, last step. See, let's say I'll explain you in a very layman language. Let's say there is very heavy box. There is a very heavy box, and 4 people are carrying that heavy box. 2 are on the front and 2 are on the back. Obviously, let's say it's a 300 kg box. They are sharing. Sharing is basically called R square. So some may be sharing 75 kg, some may be 80 kg, some may be 100 kg. Yes or no? This is what the example is. Yes. Do you agree with me? The sharing will be there whenever they are carrying very heavy box. 4 people are carrying that box. So everybody will share. Yes or no?
Yes, sir.
Yes, sir.
All right. Now, let's say one of their friend has also come. Now 4 are already there. He says, let me also help them. And he come in between and also share some. Maybe he is sharing 30, 40 kg. So sharing means R square is increasing. Sharing means R square is increasing. Right? R square is increasing. Now, obviously he is sharing 30, 40 kg. One more person has come. And obviously he says, okay, let me also contribute something. Now there are 2 on the front, 2 in the middle, and 2 on the back. Obviously sharing will increase. Sharing will increase. Load will be less. Sharing will increase. That means load will be less. And R square will further increase. That means if you include more and more independent variables, your R square will always increase. There were 6 predictors. I can include height also. I can include weight also. I can include BMI also. I can include so many others. So more and more variables include, R square will go on increasing because sharing is increasing. Now, let's say 7th one has also come into the picture. 7th one has also come into the picture. And now he is looking at, there are 6 already working. And he come in between and put just a finger. Just putting a finger. The finger will share maybe 10 or 20 gram. Yes or no? Hello? 10 or
Yes.
20 gram? Now, but sharing is there, whether it is 10 or 20 gram. Now, R square will further increase maybe by 0.0001. But adjusted R square will not increase, because adjusted R square will only increase if additional variable is making a significant contribution to predict the dependent variable. So if you include the 8th, 9th, 10th one, and they are just making insignificant contribution of sharing, then they are irrelevant variables. So if there is a big difference between R square and adjusted R square, that means there are irrelevant variables into the model. Of course, whenever you are applying stepwise regression, irrelevant variables are always out of the model. I'm talking whenever we apply enter method. So there are some irrelevant variables. So you have to be careful. If there is a big difference between R square and adjusted R square, that means if suppose your R square would have been 0.995 and adjusted R square is only 0.645. In that situation, immediately the reviewer will pick up that some irrelevant variables are there in the model. This is how the interpretation for R square and adjusted R square goes. So I'll stop here. If you have any question, you are most welcome. Yes, please. Anything you want to ask? No question?
I hope already all questions are clear, sir. This is delivering amazing session today. And
Okay.
if maybe still if any remaining query, you can ask. We have this open for 1 minute.
Yeah, please. Any question is there, you can.
Thank you all delegates for positive feedbacks in the chat box. Thank you very much.
And इसको stop कर दें sharing.
Yes, yes, definitely.
Stop sharing. Let me come back. So, if you still have any question, most welcome. ये सब लोगों को हिंदी समझ में आता है, पहले तो ये बताइए। मैक्सिमम को आता है।
यस सर।
तो अगर मैं कुछ अगर हाँ एक आधा शेयर हिंदी में बोल दूं तो मेरे ख्याल से चलेगा, कोई दिक्कत तो नहीं है।
बिल्कुल सर, मुझे लगता है
Yes,
पार्टिसिपेंट
sir.
जाने
बिल्कुल।
भी नहीं देंगे आपको।
चलिए देखिए, थोड़ी थोड़ी मैंने सोच बदलने की आपकी कोशिश की है, उसके ऊपर एक शेर लिखा है
इरशाद इरशाद।
कि हाँ, कि सोच को दुनिया में दो चीजें, मतलब किसी भी आदमी की जिंदगी में दो चीजें बहुत इंपॉर्टेंट होती है, एक उसकी सोच और एक उसकी डायरेक्शन। तो उसी के ऊपर एक शेर है कि सोच को बदलो सितारे बदल जाएंगे, सोच को बदलो सितारे बदल जाएंगे, नजर को बदलो नजारे बदल जाएंगे, कश्तियों को बदलने की जरूरत नहीं, दिशा को बदलो किनारे बदल जाएंगे।
बहुत कुछ सर।
वाह सर।
और एक आपके लिए एक और शेर कि जिंदगी किसी की मोहताज नहीं होती, जिंदगी किसी की मोहताज नहीं होती, दोस्ती सिर्फ जज्बात नहीं होती, कुछ तो ख्याल आया होगा खुदा को, वरना इस प्रोग्राम में आपकी हमसे मुलाकात नहीं होती।
बहुत कुछ सर, क्या बात है, क्या बात है।
और जिंदगी में मुसीबतें आती रहेंगी, प्रॉब्लम्स आती रहेंगी, और अगर आप सीखने की इच्छा रखते हैं तो आप बहुत कुछ सीख के जा सकते हैं, इसमें कोई दो राय नहीं। फिर भी मैंने आपको कहा है कि मेरे यूट्यूब के वीडियो आप देख सकते हैं, उस पर भी मैंने सारी ऑलमोस्ट मल्टीवेरिएट स्टैटिस्टिक्स राइट फ्रॉम द बिगिनिंग टिल एंड तक सारा कुछ सिखा रखा है। तो अगर फिर भी कभी आपको लगता है कि क्योंकि एक लेक्चर में सब कुछ करना पॉसिबल नहीं था, बट एनी हाउ, हाँ हालात आप जरूर बदल सकते हैं। तो
बिल्कुल
कहो तो एक शेर और सुना दूं।
बिल्कुल सर, बिल्कुल बिल्कुल इरशाद।
कि माना कि हालातों से इंसान बदलते हैं, सरकमस्टांसेस इंसान को बदल देते हैं, कि माना कि हालातों से इंसान बदलते हैं, पर हालात भी हम इंसान बदल सकते हैं, हम ही बदल
बहुत
सकते
सर,
हैं।
बिल्कुल सर।
और होप कभी नहीं छोड़नी चाहिए। ये मत सोचिए कि आपको आया नहीं कुछ भी, प्रैक्टिस करेंगे तो सब कुछ आ जाएगा। और उसके ऊपर आपके लिए एक शेर कि लाख दलदल हो पांव जमाए रखना, यानी कितनी भी मुसीबतें आओ, सीखने की इच्छा हमेशा होनी चाहिए, आगे बढ़ने की इच्छा होनी चाहिए। कि लाख दलदल हो पांव जमाए रखना, हाथ खाली हो फिर भी उठाए रखना, कौन कहता है छलनी में पानी रुक नहीं सकता, बर्फ बनने तक हौसला बनाए रखना।
बहुत कुछ सर,
चलिए
बहुत
आज
कुछ
के
सर,
लिए काफी
बहुत
है
उम्दा
मेरे ख्याल से।
है।
और अगर कहो तो लास्ट में एक आखिरी शेर।
बिल्कुल सर, बिल्कुल बिल्कुल।
तो इसमें मुझे उर्दू भी आता है, मुझे पंजाबी भी आता है, और थोड़ी
बिल्कुल
थोड़ी
सर।
बंगाली भी आती है, और
ग्रेट ग्रेट सर।
और पंजाबी, उर्दू, हिंदी सब आता है। और
जी
मैं काफ़ी कंट्रीज़ में भी जाता रहता हूँ, आपने बायोडाटा में पढ़ा ही
जी
था।
जी।
बट लेट मी टेल यू, जो संस्कार और वैल्यूज़ हमारे हिंदुस्तान में है वो कहीं नहीं है, इसीलिए हम लोग जाके फिर वापस आ जाते हैं। चलिए आखिर में शेर आपके लिए, इसमें एक उर्दू का वर्ड आएगा जिसका जिसका मीनिंग है अ, महफूज। महफूज का मतलब होता है संभाल के रखना,
संभाल के रखना।
और हाँ, सितारों का मतलब होता है रोशनी। तो अगर आप ये सोचेंगे तो आपको ये शेर समझ में आ जाएगा। महफूज का मतलब है संभाल के रखना, सितारों का मतलब है रोशनी। कि सितारों को आंखों में महफूज रख लो, सितारों को आंखों में महफूज रख लो, बहुत दूर तक रात ही रात होगी, मुसाफिर हो तुम भी, मुसाफिर हैं हम भी, कभी ना कभी कहीं ना कहीं किसी मोड़ पे फिर आपसे मुलाकात होगी। थैंक यू वेरी मच।
बिल्कुल सर।
वेरी नाइस
थैंक यू सर।
सर।
और
थैंक यू सर।
डेफिनेटली अभी कुछ पार्टिसिपेंट्स हमारे जो 3 मंथ प्रोग्राम में भी हैं, एनरोल हैं, जो इस प्रोग्राम में भी एनरोल हैं, हम दोबारा सर से फिर मिलेंगे और फर्दर प्रोग्राम्स में हम सर से मिलते रहेंगे ऑनलाइन।
श्योर।
बहुत बहुत धन्यवाद सर। जो हमारा, जो हम लोगों का हिंदी में है, वो जो हिंदी में स्नेह है वो किसी भाषा में नहीं है।
वो नहीं है। हाँ,
हिंदी पे मेरी भी है 2 लाइनें, बस कह के मैं सभी से धन्यवाद कहूंगा कि
क्यों
जो अर्थ फूंक दे जीवन में,
जी।
जो अर्थ फूंक दे जीवन में, शब्दों में जिसके नेह गुलाब,
हम्म,
वह भाषा प्यारी हिंदी है, मेरे भारत की बिंदी है।
क्या बात,
और
बहुत
शब्द
बढ़िया,
शब्द
बहुत
में
अच्छा।
भाव भरे हों, शब्द शब्द में भाव भरे हों, अगणित अर्थ निकलते हों, अलंकार के अंकुर फूटे, जो पांव पर भारी है, वह भाषा प्यारी हिंदी है, मेरे भारत की बिंदी है।
क्या बात,
तो
बहुत
सर
बढ़िया,
बहुत बहुत
बहुत ही
वेरी
अच्छा,
नाइस,
धन्यवाद।
वेरी इन्फॉर्मेटिव।
बहुत अच्छा।
आप सभी का बहुत बहुत धन्यवाद सेशन को और मजेदार और आनंदमय बनाने के लिए। सर बहुत बहुत धन्यवाद, आपका कीमती समय मैंने कुछ ज्यादा ले लिया सेशन में,
नहीं नहीं,
बहुत
कोई
बहुत
बात नहीं।
धन्यवाद। तो अगेन
Chairman,
सभी
yeah.
ऑर्गेनाइजर्स की तरफ से मैं आपको बहुत बहुत धन्यवाद देता हूँ और सभी पार्टिसिपेंट्स को बहुत ही पेशेंटली सुनने के लिए।
जितने भी लोग मेडिकल प्रोफेशन के हैं उनसे जरूर रिक्वेस्ट करना चाहूंगा कि दे कैन ऑलवेज राइट टू मी फॉर एनी मेडिकल डाटा एनालिसिस प्रॉब्लम, बिकॉज आई एम हैंडलिंग दिस डाटा एनालिसिस इन मेडिकल साइंसेज फॉर द लास्ट 27 years. तो कोई भी रिगरस से रिगरस प्रॉब्लम भी कोई मॉडलिंग की हो, यू आर मोस्ट वेलकम टू आस्क मी। आप इनसे मेरा नंबर शेयर कर सकते हैं, आप मेरा CV शेयर कर सकते हैं।
I will share details. So if anyone have any doubt, any support you need, you can contact sir. You can contact us at any time you need to contact sir. You can contact us. I will provide the details. You can contact with us sir and clarify your doubts, need support, any statistical support. You can contact us. Thank you, sir. Thank you again.
Okay. Thank you. Namaste. Namaste.
Presence and expertise sharing in this program. Thank you for the details. Thank you, everyone. This is the end of today's session. And scheduled tomorrow's session will be on effective discussion writing. That will be delivered by Dr. Rashmi Kumari ma'am, Associate Professor from the Dr. Ram Manohar Lohia Institute of Medical Sciences, Lucknow. So be on time. Tomorrow's session will start at 7:30 p.m. Thank you everyone for joining.